Okay, guys, we are today going to learn our second method, which is substitution. Just like I have a substitute in for me today, we're just going to take numbers and substitute them in for X or Y. So the main thing you need to have is out of the two equations, one of them needs a variable by itself. And this will make more sense. We're going to do about 4 examples today, which is going to seem a little lengthy, but it'll be worth it in the long run. Once you're finished going through the examples and writing it down, you're going to do your practice packet, page 94. And it's on the bottom. It's numbers 1 through 6. Don't feel like you have to get through all of them, but you at least need to get through some just to kind of see what you're getting and what you're not getting. So I can always help you on Friday as well if you have any questions. Okay, so let's do the first example. I'm going to start off pretty easy. I'm trying to show you a little bit of everything that you'll see. So example 1, here's our 2 equations. Equation 1 is x equals negative 2, and equation 2 is 4x minus 2y equals 18. So like I told you, our main goal is to make sure we have one of our equations have a variable by itself. And we do. We don't have to do anything to do that. It's already by itself, which is great. So if x equals negative 2 in my first one, since I want these to work together like we have been with the graphing, I'm going to see what it would be if x was negative 2 on my second one. So I'm literally going to substitute the negative 2 in for the x of my second one. So this would be rewritten as not 4x anymore, because just like if I were x, I'm not here today, so I have a substitute in for me. So you can't write the x anymore. We're now going to write negative 2 and then rewrite everything else. Minus 2y equals 18. And now we're just going to solve for y. We're going to see what y would be if we substitute the negative 2 in. So we have negative 8 minus 2y equals 18. We're just going to add 8. So we're just solving equations. Negative 2y equals 26. Divide by negative 2. And I get an answer of y equals negative 13. So that's great. I have an answer for y, and I don't really need to solve for x because I already know that x is negative 2. So when x is negative 2 in these 2 equations, then y is going to be negative 13. So just like before when we were graphing, it would cross at negative 2, negative 13. That's when they would be the exact same. This is called one solution. And on your practice, it talks about consistent and inconsistent. This is considered consistent. The only thing that's inconsistent would be a no solution. Not totally worried about that right now. I'm more worried about you getting an answer and knowing that when you get that answer, it's one solution. Okay, we can talk about consistent later. So that's example 1. Again, that's fairly easy compared to some of the other ones you'll see. So let's go ahead and erase this. And let's go to example 2. So example 2 will look a little bit different. Okay, for example 2, we're going to do our first equation is going to be negative 3x minus 3y equals 3. And then I'm going to do 5x plus y equals negative 17. Oops, sorry. So the thing that kind of stinks for this one is I told you our main goal is to have the variable by itself in one of the equations, and I don't have that. My second one is close though. So hopefully you're noticing that already. And I could get the y by itself by moving this 5x. So what I'm going to do is subtract 5x to get that y by itself. And now I have my new equation, negative 5x minus 17. So now I have one variable by itself. The other one doesn't necessarily need to. It could if you wanted, but now I have two equations. So this time though, my whatever y equals or x equals isn't just a number. It's actually an expression, but that's okay. So if y equals negative 5x minus 17 here, I want to see what it is in here. So I'm going to substitute negative 5x minus 17 in for the y in the other equation. Again, we're just using these together, and this is a way to use them together. So I'm going to go ahead and erase that just so we have some room. So you should still see it on your paper. Okay, so I now have negative 3x minus 3. And instead of y, it's now going to be negative 5x minus 17, because that's what y equaled before, and then equals 3. So I'm not changing any of the other numbers. I'm just substituting the one in for y. So this negative 3x I'm just going to kind of bring down because I'm not using it yet. And then I'm going to distribute here. That gives me a plus 15x. And then this should give me a plus 51. And now we're going to solve for x because y equaled negative 5x minus 17. So we're going to see what x equals. I'm going to go ahead and combine these two because they're on the same side. So this is 12x plus 51 equals 3. Subtract 51. So it is a lot of algebra. I know it's kind of stinks, but that's why we're in algebra. And then I'm going to divide by 12. And I get x equals negative 4. So that's half my answer. I know that y equals negative 5x minus 17 in both equations. So I would like to figure out what y is as the actual number. So I'm going to go ahead and plug my negative 4 in for the x. Since I know x is negative 4, I'm going to go ahead and plug that in. So this just comes from our answer. I plugged it in here to see what y is. So y equals 3. So my answer is negative 4, 3. Now, you type those two equations in Desmos, and it will cross at negative 4, 3, I promise you. So that's another way that you can check it, but you have to know how to solve it too. And that's one solution, and any one solution is consistent. So that's a pretty tough one because it's a lot of steps. But if you write these steps down, it'll help you for when you do your practice. Pretty much you're just solving for one variable, then plugging it back in to get your other. And again, if you type those two into Desmos, you will get them to cross at negative 4, 3. But there are going to be times where they want you to solve it algebraically like we're doing. Okay. Let's go to example 3. Just a few more examples, guys. All right, example 3, we have y equals 6x minus 11, which is nice because the variable is by itself, so we don't have to do as much work. 2x minus 3y equals negative 7. Okay, so I have this by itself. So I'm going to take this 6x minus 11, since y equals it, and I'm going to have it make y equal it here. So my new equation, because I'm putting them together, instead of y, since y equals 6x minus 11, I'm going to have it equal 6x minus 11 here and see what we get. All right, so the negative 2x, I'm just going to kind of write down here, and I'm going to distribute this negative 3. So negative 18x plus 33 equals negative 7. Again, I'm going to go ahead and combine like terms here. So this should give me negative 20x plus 33 equals negative 7. Subtract 33. I get negative 20x equals negative 40. Divide by negative 20. X equals 2. So I'm almost there. So there's that equation. Now I'd like to figure out what y is. So I know that I have y is 6x minus 11. That's what they gave us. That's what we substituted in for the other y. So now I'm going to take my x value and plug it in to see what y actually is. So 6 times 2 minus 11 is 12 minus 11, which is 1. So my answer is 2, 1, which again is one solution. The next one I'm going to show you is going to be a little bit different. So hopefully you're still hanging on with me here. You might see this on your practice depending on how far you get. And I just want you to see it so you know what it looks like. Oops, sorry. So example 4, our final example. We have negative 3x plus 3y equals 4. Then we have negative x plus y equals 3. So I've got to get one of them with variables by itself, which will be the one on the bottom. So I'm just going to go ahead and add x here. That gives me y equals x plus 3. So there's the equation I'm going to use with the variable by itself, and I'm going to put it right in here. So that becomes negative 3x plus 3 times x plus 3 equals 4. Bring this down, distribute this. All right, I'm going to go ahead and combine like terms. Negative 3x plus 3x is 0. You could put 0x, but 0 times anything is just 0. So really, this cancels out. So it leaves me with this. It's kind of weird. If you ever get something like this where your x values cancel, and the numbers are different, that is no solution. we know that no solution means that those lines never cross. They're never going to be the same. So that's no solution. And a lot of times they like to call that inconsistent. So anytime that happens where your x's cancel, it's kind of a big deal when you get that. If that ever happens and then you're left with two numbers that are different like that, it's going to be no solution. So you may see that one today too. So after this, go ahead and get out your practice packet. The sub does have a answer key if you want to get your answers checked. But again, if you feel more comfortable trying it again with me tomorrow, that's fine. But you do need to get some done so I can kind of see what you know and don't know. Alrighty, I hope you guys do okay with it. And email me if you have any questions. I will have my email open. Bye.